We talked about throughput mapping, and once we do throughput mapping, then we know where the problem is, where it lies. And in the case, let's go back to the case where process capacity, the effective capacity, is equal to the theoretical capacity. In that case, we could increase the workforce, so the number of resource units, so hire more people. We could increase the size of resource units, and has to do with bigger equipment, machines, and so on. Increase the time of operations, which means things like overtime, machines running overnight. We could subcontract. Subcontract is another solution where you could get other company organization to help you out. Or you could outsource some of the bottleneck activities. Also, you could speed up the rate at which activities are performed. So this comes with better training, so your employees could do more units per time period. So let's go into details on what we could do to increase capacity. So we've talked about this, eliminating non-value added activity. So identify the non-value added activity, again, from the customer point of view, and try to reduce them or eliminate. Avoid defectives, rework, and repetition, because all that eats up capacity. So if you avoid all that, it's gonna lessen all these things that are eating up capacity. Reduce things like breakdowns, work stoppage, all that stuff is time wasted in terms of capacity. Your maintenance policies should be better so your machines don't fail as often. Reduce setup loss. So every time we do a setup, that takes time, so we want to be quick at setting up operations. By obviously reducing setup time is key here. So move some of the work to non-bottleneck resources. So when we have not bottleneck resources, so moves that work to other resources. So if you have an employee that is really is doing a lot of work, more than the others, and that person is becoming the bottleneck, then move some of his tasks or her tasks to another employee. Now, reduce interference waste, and we're looking at two things here. Starvation, which basically means that resources are available, so people are ready, machines are ready, but the inputs are unavailable. So these are things that you're waiting for material, so waiting for material or parts, and that's starvation. So you need to reduce that, and the best option is to improve your supply chain relationships with your suppliers so things are available on time. Blocking is the raw materials are ready, the parts are ready, and your employees are ready, and machines are ready, but then maybe there's too much inventory in the system that you don't want to make any more products. It could be directives of management. Maybe it has to do with the market. Maybe the market is not behaving as good as you want it to behave. So for all these cases, this is blocking. And obviously for starvation and blocking, for starvation, better supply chain activity management, and also for blocking, better supply chain management in terms of understanding demand and managing your inventory better. So in overall bottlenecks are the most important in processes. So if you need to identify bottlenecks. So if you have a process and this happens to be the bottleneck, this is what's slowing the system down, then you have to identify it. That's obviously the most important, one of the most important steps in throughput improvement. And as we said, you want to increase capacity of these bottlenecks, whether they're internal or external. But remember something very interesting that happens. So every time you add more resources to bottlenecks obviously will disappear, but new bottlenecks will arise. So if this process, so let's look at this example. So this process is now the bottleneck. If we add more resources, so resources, what will happen is maybe this one will become now the bottleneck, right? So now we have to add resources here and so on. So there's a spiral effect, and so always there's new bottlenecks being always coming, new ones arising, and new process capacity increases and so on. So the process is gonna keep going like in circle. But every time you identify the bottleneck, new bottlenecks, and you improve the process, you tend to basically, so the improvements are decreasing at a rate. So the first bottleneck you identify, so this is the first one, it's going to give you a lot of improvement. The second one, it will give you improvement, but not as much as the first one. Then the third one is less, and so on. This is what the spiral effect is all about. So this is the last example we'll do on capacity and throughput. Example number 6, I'll leave that for you guys to do. So now in this question, we have two different products. So this is a law firm that does both shopping centers and medical complexes project. And these are the time requirements. And we have the two different products, medical and shopping. We have per number of professionals, this is CI, and these are three different resource pools, but we see something different here. We have the available hours for each one of these resource pools. We haven't seen anything like this before. A month includes 20 working days, and the firm has generated 150 orders, 75 of each, so we have 50% ratio of each. So we have 50% shopping and 50% medical. So the product mix is 50%. The unit load mix we're exactly doing the same thing we've done in previous examples. We have to use that ratio, this ratio right here. And so we'll start with paralegals. So we have 4 and 6, and each one of them is 50%, so we get 5. And if we do the same thing, we should get 2 and 1 for the tax lawyer and senior partners. So now, again, the main difference in this question is we have the number of hours. We didn't have number of hours in previous questions. We just assumed that they do the same hours every day, each resource pool. Now, each resource pool in this case has different hours. So when we calculate the effective capacity, we're going to take the number of professionals, which is 4. So let's start with the paralegals. So that we're starting with the paralegals, and it's 4. And here, and then we multiply it by 6. This is new. We multiply by 6 because each resource pool is working different hours. And then we divide it by TI, and this is TI, and we get 4.8. So we got 4.8 for paralegal, and if we do the same procedure, same exactly, so dividing the C and the TI, we should get 12 and 8 for tax lawyers and senior partners. Now, remember, the bottleneck of the process is the smallest capacity, and the smallest capacity in this case is the paralegal. So that will basically dictate the whole process, and hence the whole process, the capacity of the whole process is going to be 4.8 contracts per day. So part B of the question says, can the company process all 50 cases in August? We know in the question that there's 20 days per month for this law firm. So we take these 150 case and we divide it by 120 to get how many contracts per day, because all our numbers we've calculated in the previous slide were per day. So 7.5 is much higher than the effective capacity, which we've calculated to be 4.8 in the previous slide. So the capacity isn't sufficient. So the capacity is not sufficient to process all 150 cases. So let's do part B of the question. So we know that there is 20 days per month. That's given in the question. So the question is asking us, can the company process all 150 cases in August? So let's see how many cases do they have to do per day. So we take the 150 divided by the 20 days per month, and we get 7.5 contracts needed to be done per day. So 7.5 obviously is much higher than our effective capacity. This is our effective capacity, which we've got in the previous slide. So it's much higher, so the capacity isn't sufficient. So we can't process 150 cases. We cannot process all these cases. So now the question asks us if the firm wants to do all 150 available cases in August, how many professionals of each type does it need? So we know the unit load. We've already calculated this for each resource pool. And the hours required is just that number, 105, multiplied by how many cases there are. So we get 750 here, get 300, and 1 times 150, we get 150. So this is the hours required to meet the demand of 150 cases. Now the hours available, this number is basically, remember we had only each resource unit could work 6 hours per day, and we know that there's 20 hours per month, so we get that 120 number. And then this number is basically our overall our basically hours required, 750 divided by the hours available, which is 120, which tells us how many workers do we need, how many resource units we need. So when we go 750 divided by 120, we should get 6.25. Of course, you have to round this up because you can't hire 6.25 people, so 7 people. So you need 7 people in total. So you need 7 people in total to meet the target of 150 cases, and we do the same for the rest of the resource pools. So that's so remember we have to round up each answer, and that's basically it for the last topic of the class. We are basically finished all the material for the final examination.